Hello everyone, in this webinar we're going to talk about shaker selection, common setups and basic guidelines. We're hoping to make this webinar interesting and worthwhile. First of all, in this webinar we're going to talk about shaker characteristics, difference between shaker types, we will discuss shaker selection rules and of course testing room preparations and requirements. But our first step is to classify all available shaker types, describe their application ways, and also talk about their weak and strong points. We can classify all the vibration shakers by electrodynamic shakers, like shown here, servo-hydraulic shakers, like this, model shakers with a stinger, and drop machines. First of all, let's talk about electrodynamic shakers. Electrodynamic shakers are widely used for all types of vibration tests, which have mid or high frequencies and low displacement values. For example, such tests can be sine, random, sine, random, on random, but personally I don't recommend to use these shakers for high amplitude values shock tests. We will discuss it a little bit later. Electrodynamic shakers work principles are based on coil movement into magnetic field. These shakers have a large frequency range. They can have middleweight load masses, and of course I need to mention that these shakers have a big variety of additional equipment. For example, we can add different slip tables, different fixtures for your objects, and of course there is some kind of thematic addition to the shaker table which can help you to increase the load mass. And another important feature is that all these shakers can be combined with a climatic chamber, and in that case you can connect it with our RLC21M system and connect your climatic chamber with a Modbus TCP protocol and get the data from the vibration and the temperature during your test run. Now let's talk a little bit more about servo-hydraulic shakers. As you see in this picture, we have 4 hydraulic actuators, but in some other shakers we have another number of them. These shakers are used for limited vibration tests. For example, it can be in SRS, TTH, low frequency sines, and random. That's because this shakers has frequency range limited up to 500 Hertz, but they have a big advantage. They can handle big load masses. For example, using a pair of servo-hydraulic shakers, you can place a car or, for example, a satellite or something like that. Also, they are widely used in earthquake testing. Also, I need to mention that these servo-hydraulic shakers usually controlled by external controller, which goes with the shaker. So this part is usually produced with a shaker manufacturer. Now let's talk a little bit more about model shakers. These shakers are attached to the structure with a stinger, like shown here in the picture, and the force is transferred to your testing object with this part. The structure under test and the model shaker can be suspended during the test using components such as an elastic rope or spring to simulate free boundary conditions. For example, you can place your shaker like that or like this, and in this way it's possible to excite different frequencies of your testing object. As a result, you'll get the natural frequencies and mode shapes of the testing structure, and after that, using our model analysis software module, you can get the FRF, the modes, and see the resulting object movement. Another thing which is interesting about the shake is that they usually have a built-in amplifier, and this feature is widely used because sometimes it's really difficult to place an amplifier near to your shaker, like here. Also, another type of shakers is drop machines and special shock shakers. They are used during the shock tests like SRS, TTH, and regular shock, and drop machines are used in transient capture tests. Special shock shakers can perform high amplitude shocks on your testing object without damaging itself, and using drop machines you can place multiple sensors on your testing object and drop it and analyze the captured shock. Now let's talk a little bit more about main shaker parameters. There are 3 of them. The first one is maximum moving force. Maximum moving force is specified by the well-known formula where force is equal to mass and acceleration. In this case, m is the mass of the shaker stable, and on the load, your testing object, your fixture, and acceleration is the maximum acceleration value of the test, and F is the maximum force value. I think all of you know this formula, and for example, if we have a summary mass of object under test and the shaker stable and all the sensors as 100 kilograms, the test has maximum acceleration value of 100 G. That means that we need a shaker with 10,000 newtons maximum force value. For all the shakers, this force value is fixed. You can know it from the passport. And you need to remember that if you increase the load mass, you need to decrease the maximum acceleration value. Also, we have frequency response function. It limits the start and end working frequencies of the shaker. And also from the passport, we know the maximum acceleration, velocity, and displacement values. For the shaker, they are usually specified for sine, random, and shock tests. And our next topic is shaker selection rules. First of all, you need to compare the frequency range of the shaker and your test. For example, if we have a sine run from 5 Hz up to 1000 Hz, and our shaker has a starting frequency of 10 Hz, we cannot run this test. We can damage our shaker with such low frequency. Also, as I told you previously, you need to check the maximum load mass using this formula. And of course, you need to select the appropriate shaker for your test. I don't recommend you to use model shakers for regular sine tests or drop machines for random. It will be unnecessary, and you should select the shaker for the test. For example, if you have a huge object, it's long, and you'd better use, for example, 2 servo-hydraulic shakers instead of 1 electrodynamic. It all depends on your setup. Also, such huge shakers need a cooling system. It is shown in the passport, or if you buy this shaker, the manufacturer will tell you about this, or you can ask our support team and they'll tell you about the cooling system and they'll help you. Also, I need to say a few words about the fixture equipment. sometimes you cannot place an object on your shaker without any external fixture. For example, we have a case with some kind of payload, and we need to place it on the shaker, but if we place it right on the shaker's table, we can get the wrong data. In this case, we create some kind of slip table, which will be the size of our testing object. We have some additional place for the sensor mounting, and you need to remember that it is very important to place your control sensor in the middle of your testing object or the shaker table, because in that point you get the data which is really close to the profile of the test. And now we can talk about the shaker placement in your testing room. First of all, if you have some massive objects for the test, you should have an external foundation in your testing room. Its mass must be 10 times greater than the mass of the shaker and an object which you are testing. It's really important. And of course, you need to have access to the shaker from all its sides. It will help you to fix it, replace the equipment, sensors, and so on. Also, I recommend to have a cat head in your testing room, because sometimes your testing object will be really heavy, and it will help you. Also, if you have an ability, you should split the testing room and the control room and make some sound isolation. It will help you to take care of your engineer's health. And also, if you have an ability, you need to place the cooling system outside the testing room in some kind of additional special cooling room. And you need to take care of your power supply and grounding. It's very important for big shakers. For example, if you are running servo-hydraulic shaker at low frequencies, a 50 Hz noise from the socket will be a problem. But using grounding, you get rid of this problem. And in some cases, your shaker need to be movable. For example, if we need to test a series of different objects, we need to have an ability to change the shaker position. For example, one day we run single shaker tests, but the next day we need to run multi-shaker tests, so we need to add 2 additional shakers. And in that case, you need to have extra space in your testing room. And about main parameters for the shaker selection, during the placement, you need to know the maximum values, the frequencies, the number of axes. And it's really important to know the frequencies, because if you run low frequencies test, you need to split the shaker and its foundation from all your other room and building foundation. In that case, you will reduce this low frequency vibrations, which will influence another equipment. Also, you need to have a variety of fixtures and additional equipment which will be used during the tests. And also, you need to know that In some cases, you'll have to change the way of testing. It can be not only regular vibration tests, it can be model analysis, some kind of research, shock tests, and you need to take all these points into account. Now, let's talk about our shaker options. Using RULA technology, software, and our controllers, you can run multi-shake and multi-axis tests. We can control up to 8 shakers at the same time with multiple axes, and using all the tests, you can have multiple control channels. For example, if you have a lone object but you run a single shaker test, you can place one sensor in the middle and 2 on the sides, and in the software you can select the sensors as the control and select the control strategy. In that case, you'll get all the data from the sensors, and it will be used for control level and task calculation. Of course, we have some safety checks and emergency stop option, and we try to improve this to take care of your equipment, shakers, sensors, and so on. Now I think we can check the questions.
Yes, we have a very good question. So the person tells us, I have a shaker and the load mass is, for example, 90 kilograms. How can I find out if my shock test can run on my equipment?
Okay, let's go to our software. Let's create some kind of a regular shock test. Let's enter high amplitude value here. Here, let's select another shaker. I think we need to find a shaker with a huge maximum object mass. I think we have something. Yeah, here we have a shaker with a big load mass here, and you see it has a big value of maximum force here. We select it. And here you see that as I entered these parameters, I don't have load mass. Let's decrease our amplitude here. Here you see a warning about the load mass. And after that, in the limits tab, we have load mass parameter. We press set. And here you can enter the object mass, fixture mass, your shaker stable mass, and other mass like sensors, some fixture, and so on. We have an object mass of 90 kilograms. We press OK. After that, we apply the settings. Everything is okay because we have an acceleration of 1g. But if we set it like this, we see that we're increasing this value. Let's set it as 50. And here we are going to the limit by velocity. All these parameters are calculated according to your shaker, which is selected. Like here we have this model. We know all its limit values for sine, random, and shock. And using these values, we find out the limit values for the test, and all these values can have 3 colors. Let me show you. Here you see it's red, and if we want to run such test with a pulse amplitude of 70 G, we will exceed the shaker velocity limit, or it can be an acceleration, displacement, it depends on the shaker, and the software will stop you from running this test. Also, you need to have check for shaker limits function enabled. If we disable it, we can run this test, but it will damage our testing object. So I think I answered this question. And do we have any other?
Yes, one more question. During the test run, my shaker is stopped by an amplifier. It shows an overcurrent error. What should I do?
I think that the first point you should check is the parameters of your shaker. If you have a custom shaker, it can be found in the shaker settings. You need to take the shaker passport and double check the limit values. Also, you need to know that displacement in our software in setting zero peak. We have the minimum and the maximum point. Another thing you need to check is your amplifier, if the shaker is set correctly. Maybe you have some limits set in the amplifier settings. So first of all, you need to check the shaker settings, and after that check the amplifier. And I think if you still have problems with an overcurrent error, you need to write to the amplifier or the shaker manufacturer. And I can see that we have another question about protection tools.
Yes, so what protection tools do we have?
First of all, we have the main tool, which is used in our all tests in our software, is check for shaker limits. Every webinar tell you about this checkbox that you need to press it and enable this feature, because if we disable it and press apply, we can run this test, and during the test run we won't check the maximum limit values of your shaker. If you press it, here you see an error that we cannot run this profile. Let's set it to lower level. It's the first protection tool during the test creation. After that, we have a checking for an overrange on a channel. For example, if you're running a long test, you can have an overrange, which can happen if you have a cable break or something like that. And if you enable this feature, during all the test run, we check an overrange. Another option is placed in limits. Here we set the maximum output voltage. If we set it, for example, to 5 volts, our controller won't generate more than this value. Also, we have a voltage to acceleration ratio for startup and for the test running. It helps us to check also the cable breaks and some errors during the startup. After that, we have abort and tolerance options. Here in the graph, you see these brown lines and this red one, and we have another one here. it is set in decibels, and if during the test run our control line crosses this brown line in the test progress log, we'll see a message that we exceeded this value. And if during the test run we exceed this red line or this red line, the test will be stopped automatically. And also, if you enable this feature, you'll see a shaker line, which will be purple on the frequency graph. And if we exceed this value by amplitude, velocity, or acceleration, the test will be also stopped. Another protection option is placed in channels. Here you see that we have only one control channel, and for measuring, by default, when we select the control, we can set the shaker limit and test limit. That means that the shaker limit is checking these parameters, and the test limit is checking the test with our profile. And using this shaker limit, you can enable the shaker checking options on measuring channels. Also, you can select multiple channels as control, and here you see they are set automatically, shaker limit and test limit. If you know that you have some kind of resonances or during the test run on the shaker, you can enable a filter on the channel. On the control channels, these filter frequencies will be used during the control, and on the measuring, we will only filter this data on the graph. Another interesting feature is that we can set abort parameters for every channel. So we have this abort line and this one, but we can also add these values in G here. And I think I covered all the safety checks, and I need to mention that we have only one additional feature. It's called press start check. In that case, you'll see a message window with all the parameters of the test, all the profiles, and using this feature you can double check your settings. And also before the test start, you need to check the channels type, because if you have an AP sensor but you suddenly select it as linear, you can get an emergency stop, or you can have your amplifier error by overcurrent, because we get the data from the sensor but without an external power supply. Because it's IP type, the signal is really low. Our system is trying to increase the signal, but we again get a low response signal, and in that case we can get an emergency stop and we can damage the system if we disable the safety checks. This also can be checked by the LEDs on your controller. If your channels are okay, they will have a green color. But if we set an AP sensor, but there is another sensor connected to it with another sensor type, it will have a red color. So I think that's all about the safety checks.
Thank you.
I think I answered all questions now, and finally we can go to conclusions. So Today we discussed all 4 main vibration shaker types. We discussed model shakers, hydraulic shakers, electrodynamic, and of course special shock shakers. We talked about the purpose of the shaker types and discussed the 3 main parameters like maximum moving force, its frequency response function, which can be used during the frequency range selection during the test, and of course shaker limits like maximum acceleration, velocity, and displacement values. We talked about the shaker selection rules and of course discussed shaker placement rules and some additional information and advice about the testing room equipment. So I hope you enjoyed this webinar. If you have some questions, some more time, ask them in the question section.
I think we will be waiting for 5 minutes.
Yeah, we will wait for 5 minutes. So I don't see any questions now, but if you wish, you can write us an email with all the questions. I hope you enjoyed this webinar. Thank you for watching. Have great holidays, and I think we'll meet in the January.
Yes, thank you for being with us this year, and we're looking forward to seeing you next year in 2024.
So thank you for watching. Goodbye.